In this video, I'm going to walk you through what I identified as a bit odd in the Wetherell et al. Study when I tried to simulate the data to correspond exactly to their result. So in the Wetherell et al. Material that's covered thus far in the textbook, I have simulated the means and standard deviations to be exactly what was reported in their paper. But there was one characteristic that I didn't simulate. Even though they didn't report that, I knew based on other results that there was that characteristic associated with their data. So let me redo the one-way within subjects ANOVA based on the data that we've looked at thus far. So click on Analyze, General Linear Model, Repeated Measures, and factor 1 is called Time, 3 levels, and add those in here. And click OK. And you get a statistically significant effect suggesting that the means are unequal. However, as I recommend in the textbook, you should always look at the correlations across the conditions in a within subjects design analysis. So I'm going to do that now. Analyze, correlate bivariate. And here are the correlations you get. And I would say this is very characteristic of what you might find in a study where the correlation between the dependent variable at time 1 and at time 2 is quite large, and then it decreases in magnitude from pre-treatment to follow-up, and then post-treatment and follow-up are also relatively correlated because they're close in time. I mentioned in the chapter devoted to the one-way repeated measures ANOVA that you should see positive correlations across the conditions, and the correlations should decrease in magnitude as you go along the time period. If there were no positive correlations across the conditions, it would almost be better to do a between groups ANOVA. In fact, it would be a little bit more powerful. So let's look at the data that I call real, because these correspond exactly to the results reported by Wetherell et al. So if I go into Analyze, General Linear Model, Repeated Measures, Time, 3, Define, put pre, post, and follow-up, I get an F value of 5.69, which is lower than the previous ANOVA. It's still statistically significant with 2 and 34 degrees of freedom. This is what you'll find in the Wetherell et al. Report. Now, if you look at the correlations across time, analyze, correlate, bivariate, this is what the correlations, although they didn't report them in the paper, this is what they have to correspond to because this is the only way you can get the result. Look at that. There's nothing. There's no correlations across time. In fact, if anything, there's a bit of a negative correlation between pre and post, and then there's virtually no correlation. This is a very unusual scenario. Now, the sample size isn't very large, but it's still unusual. Why would there not be a positive correlation across time? So it wasn't reported by Wetherell at all, but if I were a researcher doing a study, I would be concerned about the fact that the correlations were so low. I'd be a little bit worried about the nature and quality of the data. I'd be wondering possibly if something went wrong. If somebody coded data improperly. I'm not making any accusations. It is possible to get these data in reality. It's just a little on the implausible side to get these sort of data. Almost always there are positive correlations across time in a within subjects factor, and it's from those correlations that you get the additional power for conducting a within subjects ANOVA. So take-home message, always run some correlations across conditions, and if you don't get positive correlations, double check your data, find out if something went wrong. It doesn't necessarily mean something went wrong, but you will definitely want to double check.